Hi and welcome back. In this video we're going to look at traversal of binary trees, how you can go through elements. So there are three types of traversal in binary trees. We've got something called in-order traversal, where the first thing you do is you go left, then you check the node and then you go right. We're going to look at exactly what this means in a moment. You've got pre-order traversal, where you check the node first and then you go left and then you go right. And finally, you've got post-order traversal, where you go left first, then right, and then you check the node. So what does this all mean? Well, let's look at a few examples. We've got three identical trees here. We are going to navigate them in order, pre-order, and post-order, and see what we come up with. In the in-order traversal, the first thing we do is we are at the top of the tree. So in these examples, we always start at the very top of the tree. And what you do first is you go left, because that's what in-order traversal means. When you arrive at a node, the first thing you do is you go left and you go to its left node. So the first thing we do is we would go to the left node. Now we are at the node 9. We are at a new node. So once again, we apply in order and we go left. Notice that it doesn't have a left node, so that's not something we can do. Because we don't have a left node here, we're going to, staying at the node 9, check the node, and we're going to, let's say, print it out. So this prints out node number 9. And now we've checked the node, so we go right, and we move over to 30. Then we go left, doesn't have one, we check the node, we print 13 out, and then we go right, and it doesn't have one. And now that we've finished going left, printing, and then going right for the node 13, we go back to number 9, and then we go back to 14, because we'd also finished at number 9. So again, what happened here is we started at 14, we went left, we appeared at 9, we went left, then we printed 9, and then we went right, and we ended up at 13. We went left, didn't have one, we printed, then we went right, didn't have one, we went back to 9, back to 14. So now we're going to print 14, since we've already gone through all of its left nodes. And then we're going to go right at 14, we end up at 22, going to go left, doesn't have one, so we're going to print it out, then we're going to go right, and then we're going to go left, doesn't have one, so we're going to print it out, and then we're going to go right, and that's it. We have finished the in-order traversal of this tree. For every node, the first thing you do is you go to its left node. So you'll end up at the node that is most left of your tree. Then you will print that node out, and you will go to the right node, and so forth for every parent. Notice how what you end up here with is the ordered list, because you started at the most left node and you made your way over to the right. So that's what in-order traversal is. Looking at pre-order, the first thing you do is you check the node, and in this case we're going to say that checking the node is equivalent to printing it out. So the first thing you do is, starting at 14, you would print it out. Then you'd go left, and now you're at a new node. So once again, you print it out, and then you go left, but it doesn't have one, so then you go right. Then you're at a new node, and you print it out. Then you go left, and you're right, but it doesn't have either, so you end up again at 14. Now you're going to go right, and print 22 out. Then you're going to go left, doesn't have one, then you're going to go right, you're going to end up at 34, and you're going to print that out. This is the pre-order traversal. Before going to another node, we print the node. Then we go left, then we go right. Notice that what you end up here is something that looks a little bit random. We're going to look at exactly what this is useful for in a few moments. Finally, the post-order traversal. The first thing you do is you go left, and then you go right, and then you check the node. So we go left, we are at 9, so we go left, but it doesn't have one, we go right, we end up at 13, now we're at 13, so we go left, doesn't have one, we go right, doesn't have one, we print it out. We're back at 9. We've already gone right, so now we print it out. We're back at 14, so we go right. Now we're just 22, so we go left, then we go right, and we end up at 34. We go left, then we go right, doesn't have any, so we print it out. We're back at 22, we print it out. We're back at 14, we print it out. Hopefully, this is not terribly confusing. All we're doing here is changing whether we go to a different node first or whether we print things out first. We're going to look in some examples in code in a few moments. So, in-order traversal is useful to get an ordered list out of a binary tree. Often is also useful for printing the tree out. If you want to show it to your users, you want to maybe display it in a nice ordered fashion, like an ordered list, you can do that with in-order traversal. Pre-order traversal is actually useful for saving the tree, so it can be reconstructed later. This may be a bit abstract because we've not looked at creating trees yet, but we're going to do that shortly. So what happens here is that you end up with a list that essentially represents your tree. The first element in the list is also the topmost element in your tree. Then you have the left side of the tree, 9 and 13, and then you have the right side of the tree, 22 and 34. We're going to look at pre-order and how we can use it to reconstruct a tree in code shortly. And finally, post-order traversal is useful for deleting the tree. We're going to briefly talk about deleting nodes, but it is a more complicated concept in binary trees. Don't worry too much if it's not fully clear what these are for and how you implement them and how you use them. We're going to look at some code samples, as I've been saying. With that said, I'll see you in the very next video.